Hello, everybody. My name is Travis Cowan. Sorry for the late start. Had a couple technical difficulties. Today we have with us Pat Karras from Multistack, and we're going to be talking about integrating heat pump chillers into your electrification design with Multistack. Pat, thank you for joining us. The floor is yours, sir.
Awesome. Thank you. I do spend a lot of time on the floor, so we'll just keep that theme going. Everybody can hear me all right, correct? Yes?
Yeah, we can hear you. Yeah.
Awesome. Great. Well, thank you for your time. It's a nice tight time frame, which is always fun. As Travis indicated, Multistack is very much involved in this electrification initiative, and today's conversation will be about the things that Multistack offers to help you and your customers meet the electrification requirements of your marketplace here in Colorado. Everybody thinks it's a magical concept, but it's not really. Electrification is simply, sort of changing the fuel mix that we use today to satisfy the heating and cooling needs of your customers. Much of it being driven by the removal of natural gas as a very strong piece of the fuel puzzle. We would offer that there may still be a role for natural gas as a hybrid part of a solution down the road, but that's part of the conversation we have as we work together to satisfy the requirements that your customers may have. It's not something that's coming or down the road. It is here. It's happening today. Berkeley, California was the first one to ban natural gas. I understand Boulder has also done some stricter natural gas usage rules in the future, as well as the state of Colorado. New Jersey, New York, the northeastern part of the country, the western part in my territory is the West region, and we're seeing it in Colorado, Washington, Montana, California, even up into Canada, Vancouver, British Columbia. So it's happening, it's here, and the good news is we got a lot of ways to address those requirements for you. It really began back in the late 1980s, early 1990s. The picture that I have on the screen now is of an application at the Mayo Clinic in Rochester, New York. That's when the first real heat recovery application, about 800 tons of dedicated heat recovery at the Mayo Clinic in Rochester, Minnesota. If I said New York, I'm sorry, but the Mayo Clinic in Rochester. What do we do? What do we have that can help you with your solutions? We have 4 or 5 different product lines. One of them is just a straight traditional water-to-water heat pump using a reversing valve. We'll talk about each of them in more detail. Another one is a dedicated heat recovery chiller, which will do both heating and cooling and simultaneous activities. A more recent addition, and by recent I say within the last couple of years, is what we call an MSF. We use TurboCore's new high lift heat recovery compressor in that application to do both heating and cooling. Those are all water-cooled versions. The last 2 are air-cooled versions, an air-to-water heat pump with a reversing valve, and an air-cooled heat recovery machine, very popular. Lots to talk about on all of these, including temperatures of hot water and maximum or minimum ambient temperatures, but we'll get to each of those as we go through the break here. The MSR, reversing valve heat pump for a heating and cooling application, typically 2 compressors per module, anywhere from 10 to 85 tons now, using a brazed plate evaporator and a condenser. Recent developments would say in many parts of the country, 13 states to be exact, effective January 1st of 2024, 410A will no longer be available. The rest of the country will still have the opportunity to use 410A, but we're moving to 454B in addition to 410A, and creating hot water up to 135, perhaps 140 degrees Fahrenheit, depending on the rest of the conditions in the facility. We also do that same type of application using 134A. We will be adding 513A and be able to go up to 165 to 170 degrees Fahrenheit. That's going to be a little bit farther along in terms of its development. 513A is not as popular. 134A was not as popular in the scrolls. So we're going to be developing that starting in 2024, and by middle of 24, we should have both 454B and 513A available in this reversing valve heat pump solution. So 13 states, just as a recap, 13 states are requiring refrigerant changes for high pressure scroll applications on 1/1/24, and the rest of the country by 1/1/25. We're using 454B, and we'll have 513A as the year progresses. Dedicated heat recovery unit. The difference between the previous version is that was just a heat pump. It was either going to cool or it was going to heat. This next machine will do both. Same setup, 2 compressors, 10 to 85 tons. Obviously, you can put them in banks. The beauty of the modular concept is you can put up to 14 of them together because the controllers will handle that. So you could do 14 85-ton units, but that's a pretty big application. And most people don't have that kind of simultaneous application. They're typically more in the 100 to 200-ton dedicated heat recovery machine. But it's essentially the same machine, designed though to be able to manage to the load capabilities that are required in a facility. Same temperatures here, 410A and 454B, 140 degrees Fahrenheit, and 134 and 513A up to 170, 175 degrees in a heat recovery machine. The key considerations here are, in order to do heat recovery, you must have a chilled and a hot water load, and really important that you understand as well as possible, because it's a difficult ask, but you have to understand what's the heating load, what's the cooling load, so that we can properly control the system and deliver the most amount of heat recovery that we can possibly do. Maximum lift in that application, about 100 degrees. I call this a bit of a new machine, and if you look in the right corner, it looks a little different than maybe a traditional multi-stack modular that you might know. But we introduced it in ASHRAE in 2020. It is a flooded shell machine with a Danfoss turbo core. Compact footprint. What you see right there is 35 inches wide by 60 inches long. So very compact, very quiet, very high efficiency. Can do it in either a packaged or a modular version, but if you look closely, notice that behind the control panel, there are 4 headers there. So it is truly a modular machine. Comes in 90, 120, and 140 size modules. Again, up to 14 banks. Typical application for a heat recovery is going to be, you're going to be able to do 100, 200, 300 tons of heat recovery. Currently today, 134A, but 513A is also available, and 513A and 134 are very, very similar in terms of their performance. We can do this application with Danfoss's TT300 and 350. If you don't know the nomenclature, those are just their standard lift compressors. But the TTH machine, available in 130 tons, is actually their high lift machine. So you're able to do more lift and continue to maintain those hot water temperatures up to 145 degrees Fahrenheit with that machine. We can also do a very large flooded shell machine. I didn't put that in here, but we can do that up to a 15-foot barrel. The largest one of those we've done in a single machine is 800 tons. So lots of choices for water-cooled applications. You go on to the air-cooled applications. I'm sorry, we'll talk a little bit about what the process is. Typically, you have a cooling load, you have a heating load. The mission here is to try and minimize the footprint of both of those and capture as much of that heat that you possibly can. Your cooling load is doing 55 to 45. We're going to grab some of that heat from that process and put it into the heat side. And conversely, on the heating side, as we work from 120 to 140, we're going to grab some of that heat, some of that cooling, put it back into the other side of the equation. So we're minimizing footprint, and we're maximizing the heat recovery capabilities of that particular machine. It can be a new application, or it can be an existing application where you actually do a side stream and put that into your system as well. So we do have the ability, and this is something that the guys from Long have at their disposal. Everybody wants to know what's my payback and what kind of savings can I get using some different coefficients of performance and some capabilities. We can look at a natural gas boiler, condensing boiler in this spreadsheet. And for the interest of time, I'll just describe what we're looking at. You've got some user inputs, some utility costs, some sizes. Once you plug in the data, it will tell you in the green areas how efficient that particular machine is. COPs anywhere up to, actually, I've seen them as high as right around 7 COP for a heat recovery chiller. So the proof is kind of in the pudding and in this spreadsheet. And the long guys all have this at their disposal if you want to now give it a test drive yourself. Going over to the air side of the equation, we've been doing this particular type of machine for about 10 to 12 years now. The first one we're going to talk about is just a straight air to water heat pump, and it's called an ARP. Has a reversing valve, and it's an either or machine. In the cooling side of the application, there's a brazed plate evaporator that provides the chilled water. Heat goes out through the coil. Now, this machine that you see is an older version. It's just got standard fans on it, but today's versions of this machine have ECM fans on it. They can have a VFD on a standard fan. So the technology has ramped up significantly with this air to water heat pump machine. When you're in heating mode, just the reversing valve says, all right, I'm going to grab some of the ambient air. I'm going to transfer that into the hot water loop using the brazed plate heat exchanger. The temperature of the hot water is driven very much by the outside temperatures here. So one of our lessons learned along the way have been physics principles dictate that the colder it gets, the less hot air you can move. However, we've developed some new technologies that use a technology called refrigerant injection that allow us to expand the compressor map and are able to do at 0 to -5 degrees Fahrenheit, 130 to 135 degree hot water with an air-cooled machine. And we're continuing to work to make that even better because we know it gets a little chilly here in Colorado as it does in Wisconsin, and we're working to expand that capability. The next machine is what we call an ARA, heating, cooling, simultaneous. So we call this the either or machine. You can do heat, you can do cool, and you can actually do simultaneous depending on the type of load. Soon available in 454B, 410A today. Size range is 20, 30, and 60 tons, and we're going to have an 85 ton, which we're pretty excited about, by the end of the year into the first of the year. We showed it at ASHRAE if you were there and visited our booth, and it's continuing to progress through its development stages. So 3 different modes: cooling with no heat recovery, heating, again, hot water temp is ambient driven, but we've got some solutions where you can get colder and still get some hot water. What it looks like on the inside has 2 brazed plate heat exchangers, one for the cooling side of the equation, one for the heating side, and then a set of coils. If you're in heat side, use 1 brazed plate heat exchanger, grab heat from the air, run it through the heat exchanger into the hot water loop. Flip it around if you're doing cooling, extract that heat, throw that heat back out into the environment and out through the coils. If you happen to be in simultaneous mode, you're doing as much heat recovery as you can and then getting rid of whatever is not needed at that point. Talked about this technology a little bit, but just to give a little bit better sense, this new ARA product line using refrigerant injection, effectively through a solenoid valve, throws some refrigerant into the top cap, expands the envelope, does, I call it enhanced motor cooling, and lets you expand the envelope all the way so that you can do -4 degrees and 130, 135. At higher temperatures, we can do up to 145 degrees, about 10 degrees Fahrenheit. You can do about 145 with that particular machine. Critically important that you understand your load as well as you possibly can, because that will dictate size of machines, programming logic, when you're in heating, when you're in cooling, and how much simultaneous capability that you have. There's another version of this called a VME2 that's a water-cooled version. So take the ARA version and assume that you're doing water-cooled and using a valve structure that can manage the diversion process for you in a water-cooled heat recovery type of machine. This is what it looks like. Standard modules, the orange valves open and close depending on how much heat recovery you're able to do based on the size of the load. Currently 410A, again, headed for 454B and 513A, and using variable speed compressors. We've been doing that for about 4 or 5 years now in this module with a Danfoss true variable speed version with a coordinated drive and compressor combination. Important system considerations: loop time critical. Got to make sure we have a big enough loop and long enough to manage the process so that we don't get into cycling. If you don't have enough loop time, buffer tanks are always a reasonable option. The stuff that you see on the right is what we do for our customers so that they understand minimum loop time, system bypass design, where bypass valves would be. Those kinds of things are all part of the selection process that the guys from Long have access to. We are big fans of what we are calling the hybrid approach. We do believe still that there, despite some of the regulation that's occurring, that there may be some need, especially in colder climates, for a backup type of system, whether it's an electric boiler or gas, if it might be available in some spots, so that a pool of options is looked at as you try to satisfy your customer needs. One of our biggest concerns is the electric grid may not be able to handle a full electrification push for some time, and so a hybrid approach may just be a necessity as we proceed going forward through this initiative. So the good news is Multistack has multiple solutions for you as we go forward into this electrification initiative. We agree with all of the things that are being tossed about, whether it be decarbonization, whether it be higher energy efficiency, whether it's lean manufacturing. All of these things can be done in process as well as comfort cooling types of applications. And we think process applications hold strong features as well for the use of heat recovery and electrification along the way. So that's a very quick tour through what we're thinking about. We'd always love to hear your thoughts, and we look forward to opportunities to work with you and your customers. And we've got a great team in Long. Long has been our rep in Colorado, Wyoming, Utah, and Montana now for going on 3 years, and they're doing great work for us. So we're thrilled to be part of that organization.
Awesome. Thank you, Pat. As you can see, Multistack does have a lot of options for us. If you have any questions about today's presentation, please reach out to your Long sales engineer. Next week, Sean Davenport-Smith will be hosting, and the title of that coffee break is "Does My Boiler Plant Need a Master Control Panel?" So please tune in for that. Thank you all for joining us. We will be in touch next week. Have a great week.